Morning, class. Hope you're all doing well. Doing good at my house. I'm just hanging out with a cow behind me still, week 3. What I'd like you to do is go grab your textbook. We're in chapter 6, lesson 3, page 216, and we're going to kind of work through some of this together. So it says, what is natural selection? In 1858, Darwin and Alfred Russel Wallace, another British biologist, both proposed the same explanation of how evolution occurs. The next year, Darwin described his explanation in his book, The Origin of Species. In this book, Darwin proposed that evolution occurs by means of natural selection. Natural selection is the process by which individuals that are better adapted to their environments are more likely to survive and reproduce, more than other members of the same species. Darwin identified factors that affect the process of natural selection. So right here, I'd probably underline overproduction, variation, and competition. Figure 5 shows natural selection might happen in a group of sea turtles. And once I read through the different 2 sections, we'll go over that figure 5. Overproduction. Darwin knew that most species produce far more offspring than can possibly survive. In many species, so many offspring are produced that there are not enough resources, which are food, water, and living space, and mates, they didn't add that, for all of them. Let's first look at variation. Variation. Members of a species differ from one another in many of their traits. Any difference between individuals of the same species is called a variation. So it's any difference between individuals in the same species is called variation. That's a good one to underline. For example, sea turtles may differ in color, size, the ability to swim quickly, and shell hardness. Then we have competition. Since food, space, and other resources are limited, the members of a species must compete with one another to survive. Competition does not always involve physical fights between members of a species. Instead, competition is usually indirect. For example, some turtles may not find enough to eat. A slower turtle may be caught by a predator, while a faster turtle may escape. Only a few turtles will survive to reproduce. Then there's selection. Darwin observed that some variations make individuals better adapted to their environment. Those individuals are more likely to survive and reproduce. Their offspring may inherit the helpful characteristics. The offspring, in turn, will be more likely to survive and reproduce and pass the characteristics to their offspring. After many generations, maybe many more members of the species will have the helpful characteristics. In effect, the environment selects organisms that have helpful traits to become part of the next generation. Darwin proposed that over a long time, natural selection can lead to change. Helpful variations may accumulate in a species, while unfavorable ones may disappear. Okay, guys, we're going to now look at page 216 on figure 5. So right here, this first one, if we were going to lay out, it says, examine the sequence below that shows how natural selection could affect a group of sea turtles over time, and label each factor in the illustration, and write a brief caption explaining what is occurring. So right here, you have all these eggs. That would be considered overproduction. The turtles lay many eggs, but not all of them survive. And then here you see a predator. Right here, they're trying to get the sea turtles as they go into the water. Crabs can try to eat them. Birds try to eat them. So not all will survive. But those, if you're looking at them, they look a little bit different, each one of them. So they have variations in traits. And that could be the color, their size, or their shell hardness. Then if we move over to page 217, you see these turtles, they're all swimming. They can be competing for food, shelter, their mates. Water's probably not an issue for them since they're surrounded by water. But so anyway, that's the figure 5. Then let's hop up here, and it says, fill in the graphic organizer to identify the factors that can cause natural selection. They've already put in overproduction. You can add variation and competition. All those causes, the effect is natural selection. And one thing they didn't talk about, but I think is key, is biological fitness. So those organisms that survive and reproduce. Basically, the more offspring an organism produces during its lifetime will be the greater its biological fitness. So take a moment, and why don't you jot that in the side of your book about biological fitness. Okay, I hopped around in the book just a little bit, so I want you to put your pencil kind of in your book on page 216, just to hold your place. And I want you to flip to page 170, because what they didn't say in this section was about mutations. And variations can occur because of mutations. Remember the peppered moths we learned about? Some environmental changes. Remember they were white because the lichen on the trees. And then when the Industrial Revolution occurred, the white ones had the trees turned brown. The white ones were easily can't talk today. Were easily spotted, and so they were picked off, and the dark ones thrived. So I wanted just to touch on mutations. So variations can occur because of that. So let's look at this right here. It says the effects of mutations. Mutations introduce changes in an organism. Mutations can be harmful, helpful, or neither harmful or helpful. A mutation is harmful if it reduces the organism's chance for survival and reproduction. Whether a mutation is harmful or not depends partly on the organism's environment. The mutation that led to this alligator's white color would probably be harmful to it in the wild. A white alligator is more visible to its prey. The alligator may find it difficult to catch prey and may not get enough food to survive. A white alligator in a zoo has the same chance for survival as a green alligator because it doesn't hunt for its food. In a zoo, the mutation either helps or harms the alligator. Helpful mutations increase an organism's ability to survive and reproduce. Mutations have allowed some bacteria that are harmful to humans to become resistant to drugs. The drugs do not kill the bacteria with the mutation, so they continue to survive and reproduce. So that was on page 170. So if you would, you can now flip back to page 217, and right there where it says variations, let's click, hold on, let me pause and click. Okay, so I just came back to 217 and I made myself a note right here. Variations, any difference between individuals of the same species is called a variation. I just made myself a note that variations may occur because of mutations. That's kind of a key point. Okay, guys, we're now going to flip to page 218 and talk about environmental changes up here. A change in the environment can affect individuals, organisms with specific traits, or entire species. Changes that affect an organism's abilities to survive and therefore reproduce lead to natural selection. For example, monkey flowers are plants that do not normally grow in soil that have a high concentration of copper. However, because of genetic variation, some varieties of monkey flowers now grow copper mines. In figure 6, you can see how natural selection might have resulted in monkey flowers that grow in copper-contaminated soil. So I'm not going to flip there yet, but if you look at page 219, you'll see those copper flowers. And then genes and natural selection. Without variations, all members of a species would have the same traits and the same chance of surviving and reproducing. But where do variations come from? How are they passed on from parents to offspring? Darwin could not explain what caused variations or how they were passed on. As scientists later learned, variations can result from changes in genes and the shuffling of different forms of genes when an egg and a sperm join. Genes such as those for hair color and height are passed from parents to offspring. Only traits that are inherited or controlled by the genes that are passed on to offspring can be acted upon by natural selection. If you want, you can do the math, but I figure you're already getting math with Miss Miller or Coach Paul, so do that if you want, but I won't worry about that portion. Okay, here we go. So let's look at figure 6, environmental change. When copper contaminated the soil surrounding the monkey flowers, the environment changed. Due to a genetic variation, some varieties of monkey flowers are now able to survive in that soil. So you look, originally they were, the monkey flowers grow successfully in healthy, unpolluted soil. Copper seeped into the soil, and then most of the flowers couldn't grow, and they began to die. But some flowers have genetic variations that allow them to survive and reproduce in copper-contaminated soil. And here what you could do is just, you could say that many can grow now in this soil, and you'd have a lot more of the flowers that had that genetic variation. Okay. And then it says environmental change. When copper contaminated the soil surrounding the monkey flowers, the environment changed. Due to a genetic variation, some varieties of the monkey flowers are now able to survive in that soil. So let's assess your understanding. A variation is it a similarity or difference between the individuals of the same species? That would be the difference. A variation is any difference between individuals of the same species. And then how do life forms change over time? Well, we know that life forms change over time, and that's because of natural selection. And then relate cause and effect. Explain how unfavorable traits can disappear in a species. And on that, the variations that are helpful, remember when I was talking about those mutations in the alligators? Any variations that are helpful will be passed down, but unfavorable ones will disappear through the process of natural selection. And then you can look at, now I got it. Now that I know that natural selection occurs when organisms that are better adapted to their environment survive and reproduce more than other members of their species. And so those that are having more offspring are more biologically fit. Y'all have a great afternoon, and I hope all is going well at your house. Miss ya. Bye.